Now in the previous video we have looked how to delete a node from single linked list. Now here we are going to learn how to delete entire single linked list. So let's say this is our single linked list like this, and we want to delete this entire single linked list from the memory. So the process is very simple. All we have to do, we have to disconnect from head and tail references from the first node and from the last node. So if we manage to delete these references, this means that we are going to be able to delete the entire single linked list. The reason for this is that if nobody is pointing to this node over here, this means that the garbage collector will delete this node from memory. Because if any node is not referencing to this node over here, it means that there is no connection to this node. So this means that garbage collector recognizes it as a garbage and deletes this from the memory. So the algorithm is very simple. The first thing that we are going to do, we are setting the head reference to null. So after setting head reference to null, this link over here gets deleted. And if this link over here gets deleted, this means that there is no reference to this node over here. And this node will be deleted by garbage collector automatically. So after deleting this node by the garbage collector, the link that reference to this second node over here also gets deleted. So this means that this second node also will be deleted by the garbage collector. And it will continue like this. So after this node, the link that points to this node also will get deleted. So the garbage collector will come to delete this node also, and it will continue until we reach the last node over here. So last node cannot be deleted because in this case, tail reference to this node over here. So if any node is referencing to this current node over here, we cannot delete it. So garbage collector does not recognize it as a garbage over here. So that's why it remains in the memory. So how can we delete this? So we have to set tail reference to null as well. So if we set tail reference to null, this link between tail and this node over here get deleted, and this means that this node also will be recognized by garbage collector as garbage, and it will be destroyed by garbage collector from the memory. So now with this we are able to delete entire single linked list from the memory. All we have to do, we have to set head reference to null and tail reference to null. So after doing so, the connection between head to first node and tail to last node gets deleted. So this means that all other nodes becomes one by one eligible for garbage collection. So garbage collector comes and destroys these nodes from here. Now let's see how can we implement this in practice. Now here, one more time inside this single linked list class, we are going to declare a new method which is deleting entire single linked list. So I'm going to declare our method after the deletion of a node method over here. So here inside this class, I'm going to declare our method like this. So method will be public void delete singly linked list. So this method will not take any parameter because in this case we don't need to pass any parameter, we just need to delete the entire single linked list. So as we explained in our slides, the logic is very simple. All we have to do, we have to set head reference to null. So I'm going to set head reference to null and then tail reference to null also. So by doing so, our nodes becomes eligible for garbage collection. So garbage collector comes and deletes the nodes from the memory. So after doing so, I'm going to print out to the console saying that the single linked list deleted successfully. So I'm going to print out to the console the SLL deleted successfully. So with this we have completed our method. So as we explained, the logic is very simple. All we have to do, we have to set tail and head reference to null. Now let's see how this is working in practice. So as you remember, in our previous lecture, we have created our single linked list like this. Then we have inserted some nodes to this single linked list over here. So I'm going to delete this part from here. Instead of deletion a node from single linked list, I'm going to call the method delete SLL. Then after doing so, I'm going to print out the single linked list one more time to the console to see that how this is working. So by doing so, we can identify that if this single linked list gets deleted or not. So if I run our code, now you see that initially our single linked list was like this. Then after calling delete SSL method, in this case, it says that the single linked list deleted successfully. Then after deletion, I'm calling traversing single linked list one more time. Now in this case, you see that it says that single linked list does not exist. So this means that we have successfully deleted entire single linked list from the memory by using delete single linked list method over here. Now let's see what's the time and space complexity for this method. So here we'll start from the first line of code, this method. So in the first line, we are setting the head reference to null. So this means that this is just simple assignment statement, so which will take a one-time complexity. Now similarly, we are setting tail over here to null, so this will also take a one-time complexity because these two operations over here are not any time consuming operation. Then at the end, we are printing out to the console this message. So we know that printing out to the console also take a one-time complexity. So this means that if you combine all these complexities over here, we are getting a one-time complexity. Now the space complexity is also O1 because in this case, an extra memory is not required to delete entire single linked list from the memory. So hopefully everything is clear about deleting entire single linked list from the memory. So hopefully everything is clear about single linked list. Basically, we have implemented all transactions that are related to single linked list inside this single linked list Java class. So I will attach this class in the resources section of this section over here, so you can download this single linked list from resources section of this course.